everyone, so in this video we're going to be talking about molality and how it compares with molarity. So believe it or not, there are two different units, molarity and molality, for concentration, and then we'll be doing some math with both of these different units. So first of all, molarity, the equation or the units for molarity is moles over liters, and this is moles of solute, which is the thing that you dissolve in a solution, over liters of solution. Molality is different. It's still moles of solute, but instead of being divided by liters, it's divided by kilograms of solvent. And it's not the solution as a whole, it's just the solvent, which is usually water. All right, so we'll be doing some math with that in just a second. The abbreviation for molarity is a capital M. For molality, it's a lowercase m, which is a little confusing because this is also the abbreviation for meters. But if it's a problem that looks like it's talking about solutions and there's a little m in there, it's probably molality. Okay, now one of these units is affected by changes in, that's supposed to say in, temperature and pressure, and that is molarity. And that's because it's got a volume unit on the bottom. Volumes change with different pressures and temperatures. So molarity is actually not as accurate a unit if we're changing temperature or pressure in the situation we're in. Molality, since it's moles and kilograms, it does not change if the temperature or the pressure changes. So we use molality when we're dealing with situations where the temperature is changing a bunch or the pressure is changing a bunch. So that's why there's these two units. Okay, and we'll be dealing with molality in the next section where we're going to learn about something called colligative properties. But for now, let's talk about how we calculate molality. So remembering, molality is moles over kilograms. This problem says, calculate the molality of a solution of hydrochloric acid where 12.5 grams of hydrochloric acid, which is HCl, has been dissolved in 115 grams of water. So we need to remember that we need the solute on top and the solvent on the bottom. So that's kind of one of the hardest parts of molality, is figuring out what is the solute and what is the solvent. But if you just remember that the smaller number is the solute, the 12.5 grams, that's going to go on top, and then the bigger number is the solvent. Also, the solvent is usually water, so that's a big hint. So we're going to start this by starting with the 12.5 grams of HCl on top and the 115 grams of our solvent, which is water, on the bottom. Okay, so we're in grams over grams, so we need to be in moles over kilograms. So we need to convert our grams of HCl to moles. So by now you should be pretty comfortable with this. We use the molar mass, so we add up those molar masses from the periodic table. So hydrogen is 1.01. Chlorine is 35.45. So we're going to end up with 36.46 grams of HCl is 1 mole of HCl. Okay, and then you can probably see, since we're trying to cancel out this grams right here, this is our grams of HCl, our grams of HCl needs to go on the bottom. And then the 1 mole is going to go on top. So if I were to solve this now, I would be in moles over grams, but I don't want to be in moles over grams, I want to be in moles over kilograms. So we need to remember there are 1,000 grams in 1 kilogram. So grams are going to cross out. Then we're going to multiply across the top. So 12,500 moles of HCl is going to be over, and we'll need to do 115 plus 36, or times 36.46. So 4,192.9. And that's kilograms. And then if I just divide those, I end up with 2.98 molality. So moles per kilogram, or you can put little m, whichever one you like better. Okay, so that's how you find molality, which remember is moles over kilograms. Okay, so these next couple problems, this one is using molarity as a conversion factor. So this problem asks us what mass of sodium chloride is in 3 liters of 2.4 molarity solution of NaCl. So, couple things. This problem is not asking me for molarity or molality. Do you guys see that? It's asking me for mass. So that means I'm not going to do this kind of problem where I'm trying to find molality or molarity. It's giving me volume and it's giving me a molarity. So one thing that you need to realize is whenever there's a capital M, that capital M can be written as moles over liters. So 2.4 capital M is the same thing as 2.4 moles over 1 liter. Okay, that's very important that you understand that. Now when you see that, oh, molarity is a conversion factor. So I can actually use the molarity to go from volume to moles, and then I could go from moles to grams. So we're going to set up a conversion problem for this one. We're going to start with 3 liters. And then we want to cross out liters, so we're going to do 1 liter and 2.4 moles. And this is a solution of sodium chloride, so NaCl. My liters cross out. If I solve the problem right here, I would be in moles, but I want to be in grams. So I need to find the molar mass of NaCl. Na is 22.99 on the periodic table. Cl is 35.45. So when we add that all up, we end up with 58.44 grams over 1 mole. So our grams are going to go up top right here. And then 1 mole of NaCl is going to go down here on the bottom. And now I'm in grams, so now I can just multiply this all out. So we're going to do 3 times 2.4 times 58.44. That's 420.8. And everything on the bottom is just 1. So that number divided by 1 would just be 1. So the answer is 420.8 grams of sodium chloride. Okay. So hopefully that made sense. That's using molarity as a conversion factor. All right, last thing we need to do is dilutions. So there is a specific equation for dilutions. And just to help you guys out, a dilution is when you have a solution and you add more water to it. So you make it more dilute. So there's an equation that you can use to figure out what the new concentration will be when you dilute something. So I should have left space for us to write the equation here, but since I didn't, somewhere on your paper or in your notes, go ahead and write down this dilution equation. The equation is M1V1 equals M2V2. And in case you don't know, M is your molarity and V is your volume. And we've seen these kinds of equations before. This is kind of like P1 V1 equals P2 V2 in the combined gas law, so kind of similar. Now, with dilutions, it's kind of helpful to draw a picture to see what's going on. So let's kind of draw a picture of this situation. It says we have 100 milliliters of a 2 molar solution of HCl. So let's draw a little beaker. We know the volume is 100 milliliters, so I'm just going to label that's 100 milliliters right there. And then it's 2 molarity. And then it says I add enough water, so let's just draw a picture of, here's some water we're adding. And I add enough water to make the volume 500 milliliters. So I add a lot of water. Now the volume is 500 milliliters. and I want to know the new molarity. Okay, so what's really helpful in these types of situations is to go through and label all the numbers in the problem, figure out what they are. So we can see that, remember, we've got M1, V1, M2, and V2. So our M1 is going to be 2. Our V1 is going to be 100 milliliters. Our M2, we don't know, that's going to be X. And our V2 is going to be 500 milliliters. Okay, now with the units on volume, the units can be anything you want as long as they match. So V1 and V2 have to be the same. And then obviously the units on molarity have to be molarity. That's the only possible unit. So we just need to plug this in now to the equation. So remember, the equation is M1 V1 equals M2 V2. So M1 is 2, V1 is 100 milliliters, M2 is X, V2 is 500 milliliters. So to get X by itself, I'm going to just divide by 500 milliliters. That goes away. I'm going to divide by 500 milliliters over here. That'll make milliliters go away. And then I'll just have molarity. So we're going to do 2 times 100 divided by 500. So X is 0.4 molarity. Okay, so pretty easy. You just plug everything in, solve for X. This is an easy solving for X because there's no fractions or anything, so not too bad. Okay, one more example with dilutions. So this one says you have a 400 milliliter solution of NaOH with a concentration of 1.4 molarity. What is the new concentration if you add 300 milliliters to the solution? Okay, so let's draw this out before I try and plug things in, and you'll see why I want you to draw it out in a second. So again, let's draw our beaker here. Let's say this is 400 milliliters, and the concentration is 1.4. And now what this problem is saying is that I add 300 milliliters. So let's say here's my beaker, there's water pouring in there, and this is 300 milliliters. So when I'm done, what is my new volume? Okay, my new volume is not 300 milliliters because I added that to the 400 milliliters. So my new volume is 700 milliliters. And I'm looking for the new concentration. Okay, so if you're not careful, you're going to just plug the 300 into the equation when really what you need to plug in is 700. Okay, so you have to read really carefully, and that's again why it's nice to draw a picture of what's actually going on in the problem. We're adding 300 milliliters, so that means the new volume will be 700. All right, so let's just label everything really quick. M1 is going to be 1.4 molarity. V1 is going to be 400. M2 is X, and V2 is 700. So we go ahead and plug everything into our good old dilution equation. So M1 is 1.4, V1 is 400, M2 is X, V2 is 700. We're going to divide by 700. And the milliliters will cross out. So we'll just do 1.4 times 400 divided by 700. So our X is going to be 0.8 molarity, or moles per liter. All right, so I know that was a long video. That was a lot of math, but you guys can do this. Let me know if you have any questions. Good luck.